Hey, my name's Stevie, and I'm a math tutor here at the Academic Success Center, and today we're going to be looking at composition of functions. Alright, so let's first recall what function notation is. So this is when we have y is equal to f of x. Or we could call it y is equal to g of x, h of x, it doesn't matter. Something of x. For example, if we had the equation y is equal to 3x plus 4, we could actually just write this as f of x is equal to 3x plus 4. And this just tells us that we have a function that the input is x. So since it's in parentheses, this means it's our input. And our output will be f of x. So if we were to look at when x is equal to, let's say, 2. So that tells us our input's 2. So we'll plug in f of 2. And any place there's an x, we'll plug in 2. So instead of x, we write 2 plus 4. And then we can follow our PEMDAS. 3 times 2 is 6 plus 4. We get 10. So we have f of 2 is 10. So this means that when we plug in 2, our y value is 10. So x equals 2 and y equals 10. So when we're talking about composition of functions, what that means is that we're going to have something like g of f of x, and this is how you would say this, it's g of f of x. Lots of ofs, and that's kind of weird, but that's okay. So what this means is instead of plugging in x into our function, we'll plug in f of x. So we're used to seeing g of x, but again, instead of x, we're going to plug in f of x. And that might seem a little funky at first, but let's do an example and maybe it'll start to click a bit. So let's say we have the function f of x is equal to 2x plus 3. And we also have g of x is equal to x squared. So we have two functions, f of x and g of x. And let's say we want to find g of f of x. And note here, you might also see this as g with a little dot and then f of x. This is the same thing. It still means g of f of x. But this little dot just tells us that we're plugging f into g. So if we wanted to find g of f of x, then that means we need to take our whole f of x function and plug it in for x to our g of x function. So we could write it like this. G of f of x, which we know f of x is 2x plus 3. So we can plug in 2x plus 3 is equal to, and then anywhere there's an x, we'll just plug in 2x plus 3. So we have x squared, so we'll have 2x plus 3 squared. And then we can work out the right side of this. Remember, 2x plus 3 squared is the same as 2x plus 3 times 2x plus 3. And then we just use a foiling, so first outside, inside, last. And I'll leave that up to you, but we should get 4x squared plus 12x plus 9. And that would be our g of f of x. So a little trick with these. You always kind of want to think backwards. Normally we read left to right. So you would intuitively think that we would plug g into f that way. But in this case, we're kind of thinking backwards. We want to read right to left. We're plugging x into f, that's our input. But then our input for g is f of x. So we plug f into g. So kind of a little bit counterintuitive there. So let's use these same equations f of x and g of x, but this time we're going to find f of g of x. So remember, we're going to work backwards, so that means we're going to plug g of x in to f of x. So our g of x function is x squared, so we're going to take f, and our input will be x squared. So anywhere there's an x in our f equation, we'll just plug in x squared. So we have 2 times x squared plus 3, which we could just write as 2x squared plus 3. And this would be our f of g of x. So hopefully you're starting to get the hang of it. We're going to do another example. This time I'd encourage you to pause and see if you can do it yourself, and then play, and we'll see how it worked out for you. So this time we have f of x is x squared plus 2. And this one's kind of funky. We want to find f of x. Now, if you're starting to get the hang of it, go ahead and pause here and try it. I really encourage you to do that. But I'm going to work it out. So here we go. So what we're going to do is take f and plug it into itself, which kind of seems weird, but that's something that we definitely can do. So f of x is x squared plus 2. So if we want to plug that into itself, anywhere there's an x, we'll just write x squared plus 2. So f of x squared plus 2 is, into x, we're going to plug in x squared plus 2. So x squared plus 2 squared. So for x, we plugged in x squared plus 2, and then we squared it, just like our function tells us to do. And then we'll just add 2 on the end. And then again, if we FOIL this out and do all the work, which I'm going to let you do, we should get x to the 4th plus 4x squared plus 6. And that would be our f of x. Beautiful. We're just going to keep plugging along. Again, I really encourage you to pause and do this next example on your own. So we're given f of x is 4x minus 1, and g of x is equal to x to the 3rd. And we want to find f of g, and this is a little bit different, of 2. So remember I said that when we have an input of x, that means we're plugging in x, and then we're plugging in g into f. This time we're not given x, we're given 2. So what we're going to do is we're going to take 2 and plug it into g first. So let's do that. So g of 2, anywhere there's an x, we'll write 2. So 2 to the 3rd, which would be 8. So now we know that g of 2 is 8. So now we need to find f of g of 2, which means that we're going to plug in our g of 2 into f. And we found that g of 2 was 8. So we'll just plug in f of 8. So anywhere there's an x, we write 8. And then PEMDAS is our friend here. 4 times 8, 32, minus 1. So we get f of 8 is 31. And to fit our problem, that means that f of g of 2 is 31. Perfect. We're going to do one more example. This one gets a little wild. So you can try to pause it and do it on your own, but I don't judge you if you don't, because it's kind of crazy. So we're given f of x is 4x minus 1. G of x is x to the 3rd. And we're given a third function, h of x is 1 over x. And we want to find f of g of h of x. All right, so remember, just think backwards. So we're going to take h of x, we're going to plug it into g. Then once we find that, we're going to plug that into f. So we're going to have 2 new inputs. Okay, so we're going to take h of x, which is 1 over x, and plug it into g of x, which is x to the 3rd. So g of 1 over x, anywhere there's an x, we plug in 1 over x, is equal to 1 over x to the third. And now using our properties of exponents, we're going to distribute this exponent into the 1 and the x. So 1 to the third is just 1, and then we have x to the third. And that will be our g of 1 over x, or, in other words, our g of h of x. Okay, so 1 over x to the third is our new input, and we want to plug that into f of x. So now, anywhere in f of x there's an x, we're going to plug in 1 over x to the third. So f 1 over x to the third is equal to 4 times 1 over x to the third minus 1, which would be 4 over x to the third minus 1. And we could just leave it like that. And remember, this is our f of g of h of x. Crazy stuff, but nothing you can't handle. All right. And that is composition of functions. You might get some crazier ones, but hopefully you feel equipped to handle those now. And good luck in your math endeavors.